Good morning. This is a full room. Hopefully my audio will come through. I have to do a selfie with everybody first, so wait till break the ice this morning. I want everybody in a picture with me. So can I'm from Texas. Y'all is a word we use in Texas to mean everyone. So can everybody like wave, say hello. Hey, there we go. We're having a good time. It's not too early. It's not too early at all. Did y'all take pictures of me taking a picture? It's great. I love it. Well, good morning. My name is Brandon Satrom, and I spend my days, nights, and weekends talking about the Internet of Things and teaching people from kids to adults to software developers to recovering software developers, if you classify yourself as such, to makers about the opportunities and the promise of the Internet of Things. Now, I have a little bit of a controversial title this morning, but hopefully over the course of the next 40 minutes or so, you'll realize that the Internet of Things as we think of it today is, in fact, dead and needs to die. But the future of the Internet of Things is what we need to be focused on. And that's what I want to spend my time talking about this morning. But first, I want to share a story. It's the story of the Internet of Things, or the story of the Internet itself, over 100 years ago. In 1880, Thomas Edison was granted a patent for the first electric light bulb, which marked a new period in human history. Everything that we're doing here today is as a result of that first innovation, that innovation of power. For the first time, we could harness electricity and that power to light our homes and cities and more. Then some luminaries, like Nikola Tesla, the great Nikola Tesla, had a bigger vision. More than just powering and heating homes and cities, Tesla imagined that the next era of human history would be defined by our ability to harness electricity. Now, in fact, Tesla imagined a future where electricity would allow us to become unchained from our devices, unchained from having to be in a place where electricity is centrally powered, where we could go anywhere and do anything. And while his vision of wireless transfer electricity still hasn't become a reality, although we are working on it, aren't we? He wasn't wrong that we would be able to carry devices in our pockets. And we may not really wear vests anymore, but we do carry devices in our pockets. And he predicted this over almost 100 years ago. What's fascinating to me is that not only was he right about that, but that he predicted the huge brain that we refer to as the Internet of Things today. And even more so, when you think about this quote and reflect on it, in 1926, he predicted the future that we call the present today. We are living in what he and many others consider to be the ideal state of humanity, the ideal place for us to be. And if you look back at our path of computing over the last 70 years, it's easy to see how we got here. From mainframes to PCs to the internet and mobile, the history of computing has largely been focused on creating smaller devices while creating a whole lot more of them. And every era on this chart, on this picture here, has been marked by more financial opportunity for those of us involved in that space than the era before it. So it's no surprise then, and it stands to reason, that the next wave of computing would follow that trend. And although today that trend is more about adding computing power to everything in the world around us, as opposed to just more computers for the sake of computing. And while we were still in the thick of the mobile revolution, pundits and prognosticators started talking about the next generation of computing involving more and more financial opportunity than ever before. Now, all of a sudden, we weren't just talking about a computer on every desk or a phone in every pocket, but a computing device in every single thing around us. And an immeasurable number of devices connected to our homes, our cities, our farms, and the very world around us. We were talking about trillions of dollars in opportunity and billions upon billions of devices all of a sudden. Who could resist such wonderful green pastures? And then, almost like the protagonist of a children's book. And this is a book that I have 3 kids and have read this book to them many times. Along the way to billions of dollars and trillions of dollars and billions of devices, the IoT had a terrible, horrible, no good, very bad day. And that's the world that we live in today. Because instead of a glorious world with connected devices that improve our lives, we have connected devices that lose their connectivity and start working against us. Or we have devices in our kitchens that need to update their firmware at the worst possible time. Or social media companies that tend to have low consumer confidence and release commercial devices that literally follow you around the room and think that that's okay. Or we have security devices with facial detection technology that is so good that wearing a Batman t-shirt might actually lock you out of your own home. At its core, the IoT is about insight and control. It's about using connectivity to do things that devices alone cannot do. And that is a noble purpose when it is used for good. But for many of us, the smarts of IoT, when we think about the smart home and smart technology, it's become less about smart devices that make our lives easier than it is about companies that use that intelligence to sell ads so that companies that buy those ads can then turn around and sell us more things that we don't need. A lot of times in the IoT and in the smart home world, we feel like the product, not the beneficiary of the things that we're consuming. And for many of us, the reputation of the IoT has never been lower. And if this is you, if you feel this way, you're not alone. Many do. And I'm here to tell you, and the truth is that where the IoT stands today really shouldn't surprise any of us. Because every trend tends to follow a similar pattern of excitement, disillusionment, and acceptance. And the IoT is no different. In fact, this pattern is so common that analyst firms like Gartner, and I'm sure that most of you in this room have seen this ever-present Gartner hype cycle. Gartner and many other firms track and map the movement of technologies through this cycle. And Gartner actually predicts that the IoT's current place in the cycle is somewhere around here. Actually, not as bad as things are going to get, according to Gartner and other analyst firms. It's hard to imagine things getting worse before they get better. But again, there's no doubt that many are disillusioned with the very idea of the IoT in 2018. So, do we wrap it up there? Is that all we need to think about as it relates to the topic of the Internet of Things? But given the future, and given the fact that we may not quite be at that place where the promise of the IoT becomes a reality, we're faced with a decision today as developers, as business people. We have to make a decision about what we think about this space, about this technology. Do we write it off as a fad, sure to fade away? Or do we double down on current approaches and just wait for the IoT to magically move up that slope of enlightenment? Or do we change our approach? And to answer that question, I want to look at some other innovations that happened during the 20th century that followed a similar pattern so that we can start to see where maybe there is hope for the IoT in the future. And let's take a few of these in order, starting with the television. Now, the TV, when it was introduced at the time, was competing with radio. And so this natural comparison drew a lot of praise for radio, of course, because it was the established technology of the day. There was also speculation that TV itself was a passing fad. And yet, it didn't take the TV long to become an essential household appliance. And in fact, by 1971 in the United Kingdom, there were more TVs, there were more houses with TVs than those that had indoor bathrooms. People preferred their television over being able to go to the bathroom indoors by 1971. Now, next, the personal computer. Many of us have lived through the rise of the PC, so we've heard some of these quotes, like from Ken Olsen, the president of mainframe maker DEC, who at the time predicted that the personal computer would never happen. Why would we want such a thing in our home? Or Thomas Watson, the president of IBM, who predicted that the worldwide market for computers would be maybe 5. And yet, by 2010, in the United States, nearly 80% of US households had a personal computer. Or the internet, a fad that Robert Metcalfe of 3Com predicted would supernova and collapse by 1996. And while I don't need to provide any data at all to illustrate how wrong Metcalfe was, one only needs to look at the growth of Amazon's stock price from 2003 to July 1st of 2018 to realize that the internet, I think, kind of was a big deal. And then finally, mobile. Now, this one is actually near and dear to my heart because I worked at Microsoft during the beginning of the mobile era when our fearless leader, Steve Ballmer, predicted that the iPhone would be a failure because it didn't have a built-in keyboard. And yet, here we are today. Apple is the most valuable company in the world, and it is 100% because they triggered the mobile revolution. So, again, question, what does it all mean? Why am I sharing these things? And what does it matter in the context of the Internet of Things? And I shared these examples because I believe, again, that as many do, every technological innovation follows a similar pattern. Gartner does too, which is why the hype cycle exists. And when you look at the innovations that I shared earlier just now, or even others like cloud computing, machine learning, AI, big data, blockchain, cryptocurrency, you name it, any buzzwordy trend, the pattern repeats. We start with a narrative that a technology is the thing that will solve all of our problems in humanity. Then, as reports pour in of weaknesses or places where the technology is maybe a little bit misapplied, like putting a Wi-Fi radio in a toaster, right? We start to think, well, maybe this isn't actually everything that we thought it was going to be. And then the narrative very quickly turns into, okay, this is not great, things are not going well, to now this is absolutely the worst innovation ever in the history of humanity. Why are we even bothering? Before we ask ourselves, well, actually, maybe this is useful, as we see examples where the technology is being applied appropriately, to then cooler heads prevailed, as a college professor of mine used to say, and now we decide, okay, I think this is actually useful technology. It's interesting to note about the hype cycle that when you get to the plateau of productivity, you're about halfway in terms of visibility, you're about halfway to where the peak of inflated expectations is. So that's okay, right? The technology is not nearly as hype-filled as it was, but we get to a place where we realize this is useful. This can change the world if appropriately applied. But the important point to note here is that these technologies don't get into the plateau of productivity by themselves. Rather, it is because of the work that individuals and companies do when an innovation is at its least popular point that it is able to ascend the slope and get to that point where it re-enters our consciousness in a positive light. And I believe that the IoT is no different. I believe that in order to truly embrace the IoT and to truly understand the potential starts with changing our perspective. And much of that perspective, in my mind, begins with, that perspective change begins with changing the way we look at the role the internet itself plays in the idea of the Internet of Things. Because for starters, when we talk about labels, when the internet itself came on the scene in the middle of the PC era, we didn't call it the Internet of Personal Computers. And then when the mobile revolution started, we didn't call it the Internet of Mobile. The internet played a critical role in empowering and enabling the success of both of these, but we didn't include the internet in its name. So why then do we insist on calling the next revolution in computing the Internet of Things, when it's just an extension of the internet itself? And I believe that we start to change our perception about the IoT, but not by not treating it as the special thing. Yes, it has concerns around security and connectivity and how you update devices at the edge and how you deal with constrained computing considerations. But it is still an extension of the internet. Not a new or foreign thing, but an extension of the internet itself. Because this period that we're in now is the most critical period in the history of technology, and this is where the real work begins. This is where the real work is happening. And we don't get there if we're focused on putting Wi-Fi chips in our blenders or burning memes on toast. Those silly diversions distract us from the real work of using the power of the internet and the power of connectivity to enable our devices to do things that they could never do before. And that's the crux of what I want to talk about over the next few minutes. The idea that the IoT exits the trough of disillusionment in three key ways. One is by focusing on solving real problems. The second is by being smarter about connectivity and security. And then the third is by embracing the internet itself. So let's talk briefly about each of those, starting with this idea of solving real problems. Now, much of the IoT's current reputation is marred by the fact that we keep putting Wi-Fi chips and cellular radios in everything and calling it an IoT device, like the Disco Dog, the world's first smartphone-controlled LED dog vest. But even this dog knows that this is a solution in search of a problem. If he could talk, he would say, "Please take this off. I'm unhappy right now." And products like the Disco Dog and countless others are what make it really easy for us to dismiss the IoT as a fad. But again, this isn't the first tech trend that struggled to find its footing early on. Some of you may be old enough to remember this. In the early days of the consumer internet, the early days of the consumer internet were very similar to the current era we're living through in the Internet of Things. In those days, there wasn't really much you could do online as a business on the internet, but everybody felt like they had to have a presence. Everybody had to put up a brochure somewhere. That led to a lot of these kinds of sites where were really just about like, hey, we're Pizza Hut. We sell pizza. Go to a store to get one, right? That was what the internet was originally. A lot of that, and then some very interesting drivel throughout the internet as well. This was not my site. This is not my homepage. Somebody else did this. But the point is that the early internet was very much a solution in search of a problem. It started as an academic exercise, a way for universities to communicate. Businesses picked it up, and it still became this repository of static content. And that's the point. Pizza Hut felt like they had to have a presence, but all they could do was market themselves. And then around 1995, things started to change. And while perhaps not the first, Amazon is definitely the best example of a company that pushed the boundary of the internet from an information platform to a commerce platform. And it didn't take very long for everyone else to follow suit. So contrast Pizza Hut's website that I shared earlier with their website of today, and it's easy to see what's changed. There are 4 Order Now buttons on the page. The call to action is clear. Pizza Hut doesn't care if you know who they are. They want to sell you a pizza right now. That's it. And that shift from dissemination of information to dissemination of commerce is the reason why the internet exploded. If the internet had stayed a collection of static documents envisioned by academics, the last 20 years of our history would be vastly different. Commerce is the reason the internet is the internet, and connectivity is the reason that it happened. Connectivity is key for the IoT as well, but for a different outcome, that of control. Because when used properly, connectivity allows us to leverage sensors on embedded devices and understand how physical things are working in the world that they exist in. When used properly, connectivity allows us to control the actuators on embedded devices to take action, to impact the world, and to solve problems before they happen, which is where a lot of the financial promise is, in actually using this information for good. So let me share a few examples of what I mean when I say connectivity enables control. Because I think there's some the way we solve real problems is by identifying companies that are solving real problems, highlighting those, and doing more of the same. One great example is a company called SmartFin, and this is a product, it's a green initiative from the Scripps Institute of Oceanography, the Surfrider Foundation, and Lost Bird 9. And the SmartFin is a device that is, you basically take an existing fin off a surfboard and screw this thing on. And this is a IoT device for ocean studies. It tracks board location, water temperature, the motion of each breaking wave, pH in the water, temperature, and more. And it streams that data using a built-in cellular radio where the data is collated to provide a picture of the environmental conditions of the water near the coastlines. Now, why is this interesting? There's obviously a lot of oceanographic studies already going on today. The challenge here is even though a lot of scientists can put buoys in the water to measure this kind of information, the hardest place that they have, the place that is hardest for them to do so is the choppy waters near the shore. Turns out that's actually where surfers like to spend their time, so this is a great case where surfers can do their thing and actually help scientists map important data about our oceans, an increasingly scarce resource. This connectivity gives insight, and insight enables us to influence and control how we respond to these sorts of situations. Another example is a product called BuzzBox from a company named OS Beehives. Now, the BuzzBox is a Wi-Fi connected device that helps monitor the health and safety of a beehive. All of the data that they collect, and it's mostly sound data from the hive, is actually processed in the cloud, where they analyze that sound data to determine if the colony is healthy, if the queen is sick or has left or has died. They have all of that information. They can actually tell you, based on the sounds they're hearing from your hive, how healthy your colony is. And they do that by backhauling all that information to the cloud, processing it, and analyzing it, and applying machine learning to provide insights that are not possible today on most constrained embedded devices. And this gives beekeepers the ability to control and manage their hives, and keeping them constantly informed of the health of their bee population. Again, another increasingly scarce resource. And finally, this is one of my favorites, there's EnviroFit. EnviroFit, in the poorest parts of the world, especially Latin and South America, a lot of cooking happens over open fires, much of it indoors, which is a health risk for people living in these homes, and it's potentially damaging for the environment. So what EnviroFit does is create high-performance, environmentally friendly cook stoves that are tailored to the cultural and cooking habits of their customers in emerging and underdeveloped markets. They pair with the national governments in those countries to distribute these stoves, and they use a cellular device inside of those stoves to actually measure usage, to measure environmental impact, so that they can not only improve their products, but so that they can report back to the governments if and how these stoves, these devices, are actually being used. Again, this is another case where connectivity is actually giving EnviroFit and their customers, these countries, the insights that they need to know how these products are actually helping improve human life and improve the environment. And I just shared 3, but there are a million different ways where connectivity adds value to the world around us. And 3 of the biggest areas that help us solve problems are where devices are hard to reach, which is very common in industrial scenarios, where the machines that we connect are connected devices are expensive to replace, and connectivity can help us solve problems before they happen. And then finally, one where devices can actually help us aggregate intelligence in the cloud to provide insights that are very difficult or are not, if not impossible, to capture at the edge. The takeaway here, and in all of these cases, connectivity enables these companies to do something that would be difficult, if not impossible, otherwise. Connectivity is the secret sauce, and IoT solutions that focus on solving real problems with connectivity will help us move out of that trough of disillusionment, because we will start to see more and more we're not just using connectivity to do silly things, but to solve real problems, to help real people accomplish real goals. Now next, I want to talk about smarter connectivity and security. So not just connecting for the sake of connecting, but how we choose to do so. So in addition to putting radios in everything and calling it an IoT device, a lot of our current problems in the IoT space stem from weaknesses in our prevailing connectivity options in this space: Wi-Fi, cellular, and Bluetooth. Wi-Fi is a simple, inexpensive option, but unfortunately it assumes a stable connection to an access point, and that is nowhere near resilient enough for systems that need a guaranteed connection. Cellular is a bit more reliable, but very expensive to deploy. And Bluetooth is limited in range and tends to be a very point-to-point connectivity protocol, so it's hard to use when you're dealing with networking at scale. What's more, by connecting every single IoT device directly to the internet, we're providing foot soldiers for the next botnet. And this is no joke. With so many devices with built-in Wi-Fi chips and out-of-date firmware, and vendors that have no interest in updating that firmware to begin with, and no ability to be updated even if they could, we have to get serious about security for the IoT to become a reality. So I believe that, and bear with me here, that for the IoT to succeed, we actually need a little bit less internet in it. And I'll explain what I mean by that in a minute. But specifically, we need to stop putting Wi-Fi and cellular radios in every connected device and start pursuing smarter connectivity options. Because when it comes down to it, the traditional hub and spoke model of the IoT will never actually work. It's not only insecure, but it can't scale to billions or even trillions of connected devices in the future. And let's look at this in the context of a home network with Wi-Fi. Every solution with a Wi-Fi chip in it today needs access to the router to be able to communicate with the devices around it. So if the device isn't close enough to the access point, you're out of luck, no connectivity. And what's worse, if the Wi-Fi access point goes offline, or God forbid catches fire, and your internet goes down, every device on the network loses its own IP address. Not only can the devices not communicate with the outside world, they cannot communicate with one another. Because they lost their connection to the outside world, they lose their connection to the network, period. And I believe that in order to succeed, the IoT networks of the future need to explore more peer-to-peer like connectivity options. And one way that the industry is evolving to explore these types of solutions is with mesh networking, which operates on the principle that not every IoT device actually needs to be connected to the open internet. In a mesh network, the only devices that have Wi-Fi or cellular radios are your gateway devices. These devices can connect to the cloud, but they also wall off the rest of the network. The remaining devices on the network have radios that enable them to communicate with gateways, but also critically enable them to communicate with one another. So they can increase resiliency of the network by passing messages between devices, and also making sure that when the network goes offline, that the network can still continue to operate. If the network goes offline from the outside world, the local network itself can still continue to function. That's a powerful concept. In a lot of these types of cases, again, if a device actually is removed from the network for any reason, the network can self-heal and is smart enough to find a new path to the open internet and ensure that its messages, that its device readings, that its actuators are still available within the network itself. Mesh devices, because of the fact that they're not shipping Wi-Fi and cellular radios on every single device, also provide cheaper connectivity with a lot of the same features and capabilities. They consume less power than Wi-Fi or cellular devices, meaning that new kinds of products like battery-powered sensors can now be connected. Mesh networks tend to get stronger the more devices you add to them. But it's important to note here that mesh is not meant to be a replacement for Wi-Fi or cellular, but a complement to those kinds of networks. So in any case where you're building an IoT solution that has multiple networks of devices, mesh gives you resiliency, redundancy, a stronger network at a cheaper cost. And a great example of how mesh solves IoT problems today in a unique way is Nest's own use case. Now, as many or all of us likely know, Nest's first product, the first product that Nest created was their thermostat, but they very quickly expanded beyond this device into the Protect smoke alarm system. Now, for their thermostat, they solve connectivity the way that most companies do today, which is they stuffed a Wi-Fi radio in the device and you connected it to mains power in your home. That's fine. It's connected to the power in your home. Wi-Fi is an okay solution in this case. But the Protect system introduced a couple of new problems for Nest. Wi-Fi radios themselves are very power hungry, and smoke detectors tend to run off battery power. So their first requirement already knocked Wi-Fi off of the list in terms of a potential solution for them. What's more, smoke detectors are a safety product, not a convenience product. If your thermostat goes offline, yes, it's going to be uncomfortable depending on the time of year. If your smoke detector goes offline, that's a serious safety concern. So Nest didn't want to deal with brittle Wi-Fi networks. If you put smoke detectors on a Wi-Fi network and the Wi-Fi goes down, your smoke detectors now cannot function. Right? So they needed to pursue different kinds of options. Now they also evaluated Bluetooth, but Bluetooth's largest weakness in this case was that it is a point-to-point communication mechanism. And one of the features of most smoke detector systems is that they need to be able to communicate to all smoke detectors in a house when one detector detects the presence of smoke or a fire. And so they created, as large companies tend to do, they created their own mechanism to solve this problem called Thread. Now, Thread is an IPv6-based networking protocol designed for low-power Internet of Things devices. For those that care about such things, it is an IEEE 802.15.4 mesh networking standard, so it falls in that spectrum. And it's commonly referred to as wireless personal area networking. Now, it is independent of other 802.15.4 mesh networking protocols like Zigbee, Z-Wave, and Bluetooth LE, but it falls in that same sort of family and space. Now, Nest didn't just create this for themselves and use it in their own products, but they actually wanted to improve the state of connectivity in the smart home, and also really beyond that, smart cities, smart farms, and industrial settings as well. So they open source Thread under the name of OpenThread and created a standards body called the Thread Group to create a specification around this and move it forward. Now, they released it to make the mesh networking technology that they use accessible to these vendors, to silicon vendors, to platform vendors as well, and to make it easy to we can create mesh systems that not only communicate with devices from one vendor, but multiple vendors interacting and working together, which is a problem in many cases, especially the smart home today. And key to the concept of mesh and local networking is this, and stacks like Thread, is this idea that devices can still function without an internet connection. I know I mentioned this already, but I want to say it again because I think it is useful to think about. Right? When the internet connection is down, you still have the resiliency of a network that you can communicate between devices. So in a case where I have a flood detector on a shop floor or in a home, and a pump controller that turns on and off a pump when the presence of water is detected, I don't need the open internet to have that network of devices to communicate. Now, when my devices and connection is online, I may want to push that information up for other systems to be able to consume. But in the context of this network, the presence of the internet is not a requirement for me to be able to manage this set of devices in a safety situation or in my home. And there are a number of options. I mentioned Thread, but there are other options out there, and hopefully we'll talk more about a few of these during the panel discussion later today. But when it comes to mesh or low power local area networking, from Thread to Zigbee to LoRa and Z-Wave, there are great options, and this space is growing. What's wonderful about this as well is there's also cases where interoperability between these standards are starting to be discussed, so you can use them together and not just pick one necessarily and go forward with it. My point in sharing all of this is to say that mesh networking, or these alternative non-Wi-Fi only, non-cellular only type solutions, are not a fad, but a legitimate new connectivity option when it comes to IoT solutions. And the key point here is that this is a real approach to IoT connectivity, and something that you should consider when you need local networks that communicate, even when an internet connection is down. Or when you want to secure the devices on your network from access to the open internet, because only the gateway has access to the internet. Other devices are fundamentally hidden from the open internet. Or you want a network of self-healing and self-managing devices that can function in a true peer-to-peer fashion. So my second takeaway here is for us to consider new emerging IoT options. Mesh networking is a legitimate option for IoT connectivity, and something that we should consider, something that we should evaluate as we build the IoT systems of the future. Now, finally, let's talk about embracing the internet. I spoke in my first point about embracing connectivity to solve real problems, and in my second about embracing the idea of new and alternative connectivity options to create more secure, more resilient networks. But I want to talk in this point not about connectivity, but something the internet did that made building solutions accessible to everyone. But first, let's talk about how connectivity itself, how the IoT has changed embedded systems in the last 20 years. Because the kinds of embedded systems that we built previously were closed, self-contained systems. The machine on a shop floor may have had a sophisticated embedded microcontroller. It may have had a monitoring system, but these things were very local. These were complex systems, but they were completely self-contained. And when a machine broke, you replaced it there on the shop floor. You monitored it there on the shop floor. All there. The system worked in a world of localized and on-premise computing. It worked in a non-connected world. But that's not the world that we live in anymore. These closed systems were a norm. They're not today. Because connectivity is about more than just putting a Wi-Fi or a cellular modem in a board. Connectivity is about insight and control. It's about moving our ability to visualize and monitor anywhere, not just the shop floor, but 100 yards or 1,000 miles away where global organizations do business. It's about enabling mobile control so that we can take actions on systems from anywhere and at any time when we need to. And finally, it's about leveraging the power of the cloud for the kinds of insights that we could never think or hope to replicate on a factory floor. The kind of insights that helps us spot problems before they happen so that we can fix machines before they break instead of having to replace them when it's too late. And while most hardware engineers are perfectly comfortable with these kinds of embedded systems, they're less comfortable with the web, mobile, and the cloud. These are areas where a lot of traditional hardware engineers have not spent a ton of time keeping up with the state of the art in technology. Now, there are always exceptions to these cases. But for many, many engineers, the IoT requires new skills beyond the ones that they have today. And that's where many of us in this room come in as software developers, as engineers ourselves. Because these new kinds of systems should be interesting to us, not because they're related to the IoT itself, but because they're an extension of the internet. And while connectivity was a big, big part of the reason why the internet succeeded, there's another equally compelling reason, and that was because the internet democratized development. Or I'll get even more specific. Hopefully, there's some people in the room that will appreciate this. To put a more finer point on it, JavaScript democratized development. And it lowered the bar to entry so that nearly everyone with a computer, a browser, and a text editor and an internet connection could build solutions. Many of us are here in this room today, myself included, because the bar to development was lowered by the power of the internet, by the power of JavaScript. And that applies to the IoT as well, actually. Because in the context of the Internet of Things, there are three types of what I call IoT apps, and this is where the lion's share of the work needs to happen. There are already a ton of hardware engineers out there that are building embedded systems. There are already silicon vendors out there that are creating connected devices with Wi-Fi and cellular and mesh radios. But what the world of the IoT needs is more developers that can build these kinds of solutions that make real IoT problems solvable. And those are IoT web apps, the things that provide dashboards and insights into systems. And IoT mobile apps, which provide on-the-go insight and control. And IoT cloud apps, which leverage the infinite computing power of the cloud to provide intelligence that we can never extend all the way to the edge. And JavaScript is a common denominator in all three of these cases. It is possible today to use JavaScript to build web apps, to build cross-platform mobile apps, and to build cloud apps. And so if you are a web developer, a front-end developer, a full-stack developer, you do JavaScript as part of your day, there's an opportunity for you in the IoT space to help solve real problems. In every case, it's possible to build apps that leverage and extend these. Whether it's actually building web apps with Vue and Angular, to building mobile apps with frameworks like NativeScript and React Native, or cloud apps that rely on Node-RED or Azure machine learning, JavaScript pervades all of these. And this is important because each type of app enables us to do things with connected devices that we couldn't previously do. IoT web apps are important because they give us a view of sensor data and they can be run across devices and platforms. And several IoT platform vendors provide JavaScript-based APIs for accessing IoT devices in a secure and safe way, but in an easily accessible way, which makes it simple to build these kinds of apps. And mobile apps are important because they also provide visualization, but they provide control of our devices. They are portable, they are ubiquitous, we all have one. And so they can be used for all types of IoT applications in remote or on-site locations. And building cross-platform mobile apps with JavaScript isn't just a pipe dream, but something that tools like NativeScript and React Native and others make easier than ever. And with SDKs from IoT platforms that make it easy to interface with devices, it's possible to build IoT mobile apps that command real solutions. And then finally, cloud applications are important because they also provide insight, but it is the kind of insight that is only possible with that nearly infinite computational power. And here, JavaScript often makes an appearance in serverless tools like Lambda and Azure Functions, or tools like Node-RED, an open source workflow engine powered by and programmable with JavaScript. Truly, I believe that embracing the internet means recognizing that IoT builders are the real full-stack developers and growing that audience by providing solutions that only we as software engineers can provide. So here's my third and final takeaway. To move the IoT out of the trough, we must embrace the democratizing power of the internet and JavaScript to build applications that exploit connectivity and unlock the insights our embedded systems are capturing. Because at the end of the day, I believe that the power of IoT is not in its novelty. It's not in the buzzword. It's not even in the things part. It's not in the ability for us to put Wi-Fi chips in embedded devices. The power of the IoT is the same power that launched the personal computer, that launched mobile devices before it, and that is the power of the internet. And if we embrace the internet and the Internet of Things, we'll find ourselves climbing up that slope of enlightenment and grasping that opportunity soon enough. Thank you all for having me here today.
Unfortunately, only are able to have a couple of questions because we're behind schedule. So, any questions for Brandon? Okay, Brandon will be available during the next time slot in the Panorama room. So, if you'd like to have a chat with him or spend some more time, you can find him there. Thanks again.
Thank you. Thank you.